Greetings, you've landed at the VUC, IP Communications and VoIP community. We would like to thank Simwood.com for their support. Simwood can turn you as a developer into a telco. Our hosted PBX is from onsip.com, and you can go to getonsip.com for a URL people can click to call you. We've been privileged over the last 5 years to be using the best conference bridge on the planet. Yes, I'm talking about zipdx.com, full color, full featured, full HD conference bridge. Our website, vuc.me on the webs, hosted by bluehost.com. And our worldwide local rate dial-ins are from voxbone.com. That's right, you heard it here first, and this is VUC 591 for April 29th, 2016. We're going to be talking latency, jitter, and talking with Jason from Megaport in just a moment. First of all, a couple of announcements, as always. We'd like to invite you to check out the OpenSIPS Summit 2016 in Amsterdam. That's the 10th, 11th, and 12th of May. We'll be doing a special VUC kind of broadcast of some kind. We're still arranging the details. And none of the VUC people, including James, who's eating something at the moment, know about it. But it'll happen soon. So there's that. And, of course, there is, let me find Michael here, Camellia World. And that's Berlin, Germany. Boy, Europe is really spoiled this time. Berlin, Germany, May 18th to 20th, and many of us will be there, so show up. Jason can't make it. He was at one of the European things in Lisbon a while back. This is Jason. I'm going to show you. Jason, are you ready? You're on camera. Hey, Jason.
Shocking. 1, 2, 3. How are you? Great to see you, hear you, whatever, Randy, and the rest of you guys. It was far too many moons ago since I was over there, and now I see all these great summits happening. Anyway, I'll get to the Europe bit because there's some exciting news there.
Okay, and I'm trying to. There we go. My camera. So, okay, we're going to talk to Jason in just a second. Anybody else? Am I missing? By the way, we're honored to have Dave Todd with us. Dave, hello. He's. Let me show him. He's muted, but there he is. Yes.
When someone says latency and jitter, I go, bah.
You're right. And we're going to have to talk about your work, Dave, in just a few minutes. Andy, if you'd please check the YouTube, if I can look at something. Yes, he says live is good. Okay, great. So we are live. Got Mr. Tim Panton. Tim, I'm going to ask you to make a quick comment on what you're doing next week, too. Or is it too?
Right, yeah. Next week, I'm going to Reno to do an interactive sculpture with Debbie Davis and a crew of helpers. And then the week after, I'm in Santa Clara at the IoT World Expo, World something. Anyway, that's the plan.
Tim is tweaking Debbie's software to make her stars light up.
This is entirely true. This is wholly and completely true. And the one you see behind me is, I think it's about 1/10 of the size of the real thing.
Wow. Is it fully interactive?
Actually, yes. So the deal is that the interaction that we're planning, and this one already does, is that it starts off twinkling softly, and then there are, I think, 250 RFID tags spread out on little stars around the festival, with notes on them to bring them to the big thing. And then when you bring it to the big thing and you offer it to the big thing, the corresponding star on the big thing lights up brighter and stays that way. So over the course of the festival, the idea is that the sculpture gets brighter because of the attention you paid it.
RFID and IoT. I'm in the right place.
Yeah. Well, and these tags turned up the other day, and I started trying to work out how to make them work. So it's still a work in progress, but we're getting there.
Very cool. And I guess it would be unfair if I didn't say that Michael's here, and he's one of the co-producers of this thing. Hey, Michael, let's see if your audio is working.
Yeah, it's working. Well,
you sound great.
Winner.
You sound great. So now there's the only thing left to do is introduce Andy. Andy, you're not out smoking a cigarette.
Don't doesn't happen all the time, you know. I catch fire occasionally instead of just smolder.
All right. So here's our main guest. Well, let me do this. Here's our main guest, Jason. Jason, we probably went through how you even got into technology? You know, that's the question we ask everybody. We've probably done that already, or have we?
I don't think that we have.
I don't think so
but
either.
to ask it's kind of going back many, many, many moons, as you can probably imagine. Look, I have a bit of a personal story that I'd like to share because, you know, it's 2 a.m. on a Saturday morning, as you do. You just hang out in front of the computer and Hangouts. Going way back when, this is actually back to school days, we had, you know, the wonderful world of X25. We had a system called Discovery here, and there was, you know, not only the 80-column Discovery 80, there was Discovery 40, which is almost like for the UK guys, the teletext version. And this is my personal exposure. I've actually don't know my father, so I don't know my father's side at all, but I knew his name. And I did a quick, I guess the equivalent of a Google back in the day, and I found out that he was one of the first pharmacists advertising services online. So he was not the right pharmacy, not the wrong pharmacy. That's probably one of my earliest memories of tech, weirdly enough. But obviously, I'd sort of started on that journey, and you know, the whole online ethos and getting things online and hooking bits together, and the electronics part was definitely very key for me back in the early days. Still continues today. Still got the bug.
And what was your first experience with VoIP, for example, which brings most of us together, even though none of us care about it anymore?
So maybe not voice over IP, but it probably doesn't shock anyone that I come from a broadcast background. So I started with AM radio stations and actually getting some of the more analog. I mean, they still had carts back in the day. I probably showed my age there, but converting a lot of those systems to digital and, you know, PCM modulated recordings to VHS tapes. I think they were using it was, you know, VHS had just come of age, but they were using it in the digital fashion and then sending those over the long-distance tie lines. So yeah, before VoIP was VoIP, trying to do something a little bit more high bandwidth as well.
It's funny how, again, this is something that has probably caused us, most of us, to meet, those of us who are on the call now and people on ZipDX. But ironically, a lot of us are not really following VoIP anymore. Tim and I were just talking about this the other day. Anyway, Jason, you're here for to talk about latency, and Carl Fife left the call, but he's back. So we have
I was going to say maybe that's a good thing. That's not the primary part of the talk, but
I know.
Can we save the latency and jitter questions to the end? Maybe I'll you know, warm up after the 2 a.m. start.
Totally. We're going to go where you want to go, Jason.
Stuff in the middle. Awesome, thanks, Randy. So yeah, who's heard about a little tiny Aussie startup called Megaport before me?
A couple of hands.
Yeah, that's awesome. I'm gonna overload you with some lovely slide deck that I'm going to, of course, bounce between. So this is one of our megaported cities, Chicago. So Megaport exists at the moment in Asia Pacific and the US. I'm, of course, looking after the Asia Pacific region for Megaport in terms of I'm the solutions architect there. And I've actually just had the pleasure of spending a week in Sydney, got back just today or yesterday, as the days may be, with Amazon Web Services. So we're working very closely with a lot of the major public cloud providers. And I think a critical piece of infrastructure for these guys as they scale out and scale up, and obviously people try and do some more creative use of those services, but try to avoid those pain points. You know, routing over the internet to public cloud has certainly been a bit of a tricky concept for a lot of people. Megaport started 2.5 years ago. We've got a founder here called Bevan Slattery who was very involved in the data center business, and running and starting a few data centers, you know, it was a bit of a chicken and the egg problem for him, where if you didn't have the telco circuits in, how do you attract customers to those centers? Some of the things that, you know, in starting a data center, I guess you're contending with is, okay, I want to bring them in, but it's a very manual process to do that. So if I want to get a connection to a remote data center, I've got to get the letter of authorities. I've got to go and talk to the right people, drag the telco lines in. The time and the money starts mounting up. So I think he was definitely looking at a better way to make that happen, and that's how the concept of Megaport was really formed. I think in a nutshell. Cloud providers as well. Obviously, that's part of it. Most people know where their local clouds are, and they're not usually so local, and they usually let you connect or throw a piece of fiber to them, but only if you're within those four walls of their data center. So if you don't happen to be in that same data center as the cloud provider tails, then you're going to be accessing it over somewhat contended internet services or very expensive lease capacity in a lot of cases. So Megaport is looking about creating, I love the word or words, elastic interconnection fabric. What does that really mean? Shrugs. I'm just going to click back and see. What are people saying? So the big thing about a fabric, I mean, you probably heard the term in relation to a switch. You've got multiple services on that switch, but it's not in a physical single location. You're now distributing that switch over multiple data centers in multiple regions. And what that means is that you can have a single port that can then gain access to every other port that's on that fabric. The elastic bit is the cool part. We're doing it and the ability to scale up and scale down in real time. So you might only be using 1 megabit per second, but you might need 1 or 10 gigabits per second, and it's quite possible to do that all in real time. We do use the words SDN, so software-defined network. I mean, we use an SDN-based network internally, but the really neat part, I mean, anyone can come in and really create what we've done if they have the time, the money, and the drive to make it happen. But the brilliant part of it is the software that we actually use to interact with people, and I'll do a little bit of a demo. As I said, I'll pray to the demo gods. Elastic connectivity, as I said, we're trying to align the economics of networking or telco with what we're seeing from cloud. So the cloud providers and what they're doing with CPU and what they're doing with storage, you don't go there and sign up for 12 or 24 or 36 months. You go to them and you say, I need to use this resource. I think I need about this much. At some point in time, I may need a bit more, but quite possible tomorrow I'll just switch it all off again. So if you can imagine doing that with telco circuits, which have traditionally been, take out this long-term lease and sign away your firstborn child or your left arm or your left leg or both, the ability to do that as it's got there as short as a day or as long as a year or a couple of years, and scale it up multiple megabits per second to multiple tens of gigabits per second. So it's quite scalable in that way as well. What does a cross-connect look like? A virtual cross-connect for us can be between two data centers, so we can just provide a layer 2 MPLS circuit. Here's a VLAN on one side, VLAN on the other side. Anything you want to carry across that, go for your life, do what you want to do. But quite commonly, that does require a port on both sides. So obviously we're getting you an optical connection. The traditional way of doing it is, or actually our way of doing it is 1 gig or 10 gig per second optical port, and I've got some specs on what they are in our standardized format. As you can imagine, there's a lot of process automation in there as well. Once you have those, and if you've got two, it's quite easy to say, I just want a virtual circuit between those. But there's also other customers and partners that are on that network that you can also connect to. These are our APIs, which is also driving the system. So we actually use our own API as part of our web portal, which we've just reviewed in the last week or two. So there's a new release that's come out. Underneath that, there's a network API. The agents layer that you see there is effectively the SDN part that's then instructing our hardware. So when a person comes in from the top on that green layer, either through the web, mobile, or the API, it actually makes those calls straight into the database. It sanitizes it, checks it, throws it to the router, and it says, you need to do this, and it does it within about 60 seconds. I'll pause there for a second and see if I've got any questions before I kick into the demo.
Carl?
Don't you dare, Carl. We want
Anybody?
And he's gone.
Don't you dare.
And
Demo.
the demo's coming, James. Nobody has any questions. Okay.
Even better. All right, so this is where I pray to the demo gods, and I need to see you all do this, please. James, you know the drill. Thank you. I did speak about our locations. I'm just going to talk about that briefly before I kick into it. So at the moment we're primarily from Australia first, but we've just finished a very extensive US-based rollout. Also Singapore and Hong Kong, you can see that are lit up on the map there.
Can
I'll
you
just...
spot something missing? Something
Um,
really blatant there?
No, none at
South
all.
America.
I don't know what you're talking about. No, I do have some news, and I don't come to these things without some good news, and that is London, Amsterdam, Dublin, and Stockholm are next.
London and Amsterdam are pretty good.
That's handy. That's good to know.
Very handy.
All right.
Very key to certain people.
That's what I want to hear. That's why I'm here for you. Let me just pull up the quick slide. Actually, I'll just go through them at the moment. So US, I'll come to this after the demo. US is 29 sites and growing. At the moment in Asia Pacific, we have 41 sites. The really cool part that I get to announce also that only just got switched on today is that we're starting to bring up some international capacity. Before today, we've had New Zealand connected back to Australia. As you can imagine, New Zealand, you guys mostly probably know where New Zealand's sitting, multiple hours and a fair bit of water between Australia and them, and they don't have any of these cloud services. They don't have a lot of options for connectivity, but they're able to take advantage of these services as well. So New Zealand has been on the fabric for a while, but it's been our only piece of subsea capability. But as of today, we've actually just enabled Hong Kong and Singapore. So it's possible to, for example, if you're in Hong Kong, use the Singapore Amazon Web Service Cloud because they don't have their own region in Hong Kong. So it's really about democratizing that. They're not the only pieces of international bandwidth that we've got. That's definitely more costly than the multiple loops of, I guess, Metro Ethernet circuits. But being able to use an API and say, I just want this link to sit roughly idle at 1 meg per second. I know that it's up. I can test it. I've got the capacity there. And then say, all of a sudden, I have this requirement to scale this up to 1 gig per second. I can do so, and do so within 60 seconds, and I don't have to reserve or pay for that capacity. So, on to the demo. Are we able to see this?
Yes.
Yep.
All right. This is our Megaportal. And I love the creatively named Megaport.al because everyone goes, isn't it in Albania? It's not. It's just our marketing guys. They love little puns like that. So, come on, somebody. I'm going to log in with a demo account. All right. I think demos that show, white screen. I'm going to talk about what I'm going to do first. So there's a port in there right now, and it's live, and that's what green. It's always good. That port is connected to Amazon here. The cool thing, if anyone is watching this either now or later from Australia, that's actually a connection from a port here in Brisbane, where I am, all the way through to Sydney. So it's been something that we've provisioned. I just let that one sit in there, but I'm going to go and make a new one. So I'm going to type in the label and call this the VUC demo and pray. Then I'm going to tell it where I want to be. And you can see the markets that I spoke about there. So if I click on Australia, I'm going to see all the sites. And they're the major players. Most of you will probably know Equinix, Fujitsu, Global Switch. We have a couple of local pieces, NextDC, Pipe Networks. These are all Australian data centers. I can go over to New Zealand and see the ones that are there in Auckland. But most probably are going to want to see, and I'm going to pick on you, Michael, if you're around, US-based data centers. Give me one near you. Go. As evens do. Hurriedly unmuting.
A data center near me. So that's an interesting. I mean, who's up in Dallas? There's a bunch here. Software.
Oh, there's one. There's
Software.
one. Equinix DA1. I don't have SoftLayer in there, sadly. I've got Telex Equinix core site, but there is Dallas there. That was the one I was hoping you were going to pick. You weren't watching the screen.
Okay.
I caught you unawares.
Well, I wasn't reading, is what it was.
Oh no, that's okay. It is a bit small. The other part is then, and I'll just go back over to the left here, we've got a minimum term. So I said this is about synchronizing it to cloud economics. There is a minimum of 1 month for the ports, but the actual circuits that go between them can be done on a minute-to-minute or a day-to-day basis. So if I pick 1 month there, I'm going to get that on a rolling month capacity, or I can actually scale it up and get a discount on that. And how fast do you want to go? What's the speed of the optical port? I can then pick 1 gig per second or 10 gig per second. The eagle eye observers here will be seeing this bit down the bottom, so we're actually at 350 US a month for the 1 gig or 500 US a month for the 10 gig, which is quite competitive in that space.
Sorry,
And we've just
where is your end of this pipe? Just out of interest. Sorry, the user end, and how
these are all ends of the pipes. So at the moment, the one that I'm creating. The one that I'm creating, if it's a single pipe standalone, so if I've just got one in Dallas, that is a very good question. Where do you want it to go? If you're not in one of these facilities, I'll take the example here in Australia. If I'm not in an Equinix facility and I would like to get a connection to Amazon Web Services, they offer that in Equinix facilities, but I would need to physically take half a rack of space and rent that from them, even though I may only want 1 RU of actual routing equipment in there.
Just more loving.
Okay, by the way, Jason, since we have a pause here, there's a question on IRC. Does the New Zealand portal serve Hobbiton?
It should. So
I guess that's supposed to be funny. Okay.
The second, yes, it is.
I think I got it.
The second extension, and I'm actually hopeful we do, to be honest, because I know when they were making that film, they had a lot of bandwidth requirements, as you can imagine. There was a lot of CGI. The other part of it is, at the moment, obviously, we take New Zealand, and this is to James's question as well. If you're not in one of those data centers, they're probably the best connected places on Earth. So it is actually quite cheap. Well, it's not from us, but it's very cheap to get into those facilities. If you only want to get capacity, say on a dark fiber or a lease circuit, what's usually difficult is those minimum term commitments and how large a rack space you'd like to take. But the piece that I just wanted to touch on was this last bit, marketplace visibility. So if I'm not just doing a layer 2 circuit between 2 data centers, I may actually have a service that I want to sell. You know, my half a rack in one of those data centers might be something that I've created. I might have a startup business, or it might be something that's been running for some time, and I can actually list that as a target, so as a BN destination. If it's just between 2 of my private ports and I just want some bandwidth on tap, I can click on private. But if I actually want to put myself into the marketplace, think App Store, those sorts of things, I can click on that public button. But I'll just choose private in this case, and we'll go add to shopping cart. All right. Now I get presented this lovely list of what we call tiles. And tiles are the where do you want to go today. So I have Amazon.
Amsterdam is clearly a very good place.
Amsterdam does have a very good internet exchange. That is actually a recent addition to in certain markets that we have. I'll demo that. That's not what I'm showing today, but thank you for asking, James. So AMSIX, or Amsterdam Internet Exchange, in the US exists in these facilities. So I've got Telix New York, Equinix Chicago, and CoreSite in Silicon Valley. Now, once again, to get AMSIX, and what an IX is, for those that aren't familiar, is it's basically a peering exchange. It's these guys aggregate connections from the major players. Think, Microsoft. Think Akamai, Google. Imagine any of the CDNs or any of the whatever we're doing today over YouTube. They're going to be getting a large amount of content and aggregating those routes. We're able to do, once you have a physical port on our network, a virtual connection to those and get all of that traffic for absolutely no cost. So it's a $0. It's quite a sticky attachment to say, look, I need to pay $500 a month for the port, and I'm going to do something interesting with it. But by the way, I can actually get access to all of these routes that I might be paying transit internet costs for. So I'm quite keen on showing the AMSIX piece, but it's not the demo I have to do today, but I'm glad that you pointed it out, because it is actually something that I think is quite cool. All right, so what I'm going to do, and I have open in the other window, here's one I prepared earlier, Amazon. Who's played with Amazon Web Services? Hopefully someone that was talking about IoT before, Tim.
And you, Andy, don't put your hand up. He denies everything.
I haven't
Deny
played with Amazon
everything
Web
in this
Services. I am denying playing with Amazon Web Services because I haven't.
Oh, right. Okay.
That whole UX there, I remember thinking, oh my god, which one do I press? And it it stays like that. You dig through, and each page is just equally busy and confusing until you.
I would completely agree. I have seen some really cool ways to do shortcuts, but this is the bit that I like now. So instead of just going back out and seeing everything dumped in front of you, and I was, hovering over the IoT bit there, if you saw that. But services is really, basically categorizing things for you, and this is a fairly new addition. Oh, there's this one called networking, and within networking, there's this one called Direct Connect, and that's what we're going to show
That's
you.
where this is going. And buried in there.
And buried in there is this little thing called virtual interfaces. If I was to say I want to create a connection, you'll note that the only places that I can create a connection there are Ashburn, New York, and Equinix DA2 in Texas. What have I selected over here? Oh, I'm in DA1, so I don't have a connection in DA2. That's fine. I will go and make one. Is that what we want to see?
Yeah.
So all I need to go is to my account, and you get to see my address here and my account. I'm happy to share this with the world.
I'm
and caring guy.
getting the drift of this now. This is doing in minutes what would normally take weeks of.
You are definitely correct. All right, so I'm going to say I want to go to Amazon, and I'll note here that what region am I in? I'm in US East 1. This is kind of cool because I could even choose, I want to go to US West, but for this case, I'll pick US East 1 because I want it to land in the right place. VUC demo is me. How many megs per second do you want? I think a gig sounds good. And then I just tell it what VLAN I want it to land on my gear. So what do we want? 1, 2, 3, 4. Nice creative VLAN. The monthly rate on that is additional to the port, but I don't need to pay for the BN port. So for a 10 gig port,
$200 a month.
I know, it's breaking the bank.
The promo code is VUC 16.
We do have promo codes. I will happily take questions on those after the call. So I'm going to use here, I just want to create something to go into my VPCs. Okay, so I've got some virtual machines that are sitting there, so I can use private. If I was using S3 or Glacier storage, I could choose public, and I do need public IP addressing for that, but with private it keeps everything on my RFC 1918 addresses. Here's one I prepared earlier, so you might have seen me copy this account ID, and I just go and plug that lovely number in there.
We know where you live, Jason. You can't hide.
I don't want to hide. I want you to find me. So the sum total for my 10 gig port and my 1 gig connection into the cloud is going to be $700 a month. That $500 for that 10 gig port, I could actually do multiple connections now. If I had a 1 gig port, I could obviously only do 1 by 1 gig connection. But this is not the be-all and the end-all. I want to show that one port can do multiple things, and I'll show that in a little bit. I'm going to test the waters here and make sure that everything's running. It is 2:30 here, but it is of course other times in other parts of the world. So I have the complete trust in pressing this button, which is actually building stuff. What it's actually doing, going off in the background, is making sure things like that VLAN is not taken on that equipment, that the network routes, because I'm actually not going Dallas to Dallas here. I'm going to New York from Dallas to connect. It's still that same flat rate. So whether I was going between the two data centers in Dallas or whether I was pushing that traffic elsewhere, and I just heard the latency police come and call me. The other part is I'm not going to press refresh on this too often because, as I said, it is about a minute. What I'm going to do is, whilst that's working in the background, is build the same thing but with Microsoft. Boom, boom. Anyone? Deep intake of breath. All right. Who's looked at Azure?
No.
No.
Oh. So Azure is starting to do some interesting stuff. For anyone that's been looking at Office 365, that's pretty much hosted in most of the Azure instances. Now, I will indicate that with Microsoft, if you're using Office 365, for example, you're doing Skype for Business, this is one of the only cloud services that will not only give you a back-to-back SLA with us, but it will actually honor QoS tags. So you're able to
Well,
push.
that's worth knowing.
Yeah. There you go. All right, so they have this concept, as Amazon have Direct Connect, the concept with these guys is the express route. Once again, it's just like putting a piece of fiber into one of their data centers. So I can say I want to add an express route circuit, and I do wait, and the
Damn
spinning
you,
ball.
Jason. You know we're going to have to go and investigate this now.
Oh, I know you
As,
do.
as
I
if
may not have done this accidentally. You may need to investigate what we're doing in Europe. So this is a list of all the providers who offer express route services. Oh, there's one called Megaport there. UC demo, ER, where do I want it here? Oh, there's Dallas, look at that. And the bandwidth, I can actually spin up from 50 megs a second to 10 gigs. Now, I will indicate here that we do absorb the monthly port charge for the B end for AWS. So if you're actually pulling up a 10 gig connection to the cloud with AWS from any of those data centers that I showed you before, you'll be paying $1,600 US a month just to AWS. On our side, we'll absorb those costs, even on that $200 circuit. We don't do the same for Microsoft. We don't have that agreement in place. But the good news is, if I was to pick, say, a 50 meg circuit, there's this thing here called SKU. And the SKU for standard is what you'd use if I'm just going to do some virtual machines. For Office 365, you needed to pick premium previously, and that was an extra $3,000 US a month. If you come over to the Megaport website and have a look at our blog, you'll see an article that I've written. They actually dropped that to, I think it was about $70 a month for the standard to $155 for the premium. So now it's actually making Office 365 Express routes somewhat more practical. But before it was definitely something we saw people go, sharp intake of breath. We really are not able to look at that at the moment, because if you're doing alignment to cloud economics, there's no reason to put that sort of a scale up there. So I'm sitting on a pay-as-you-go. I'm going to pick one of my resource groups, and I'm going to put that in the West US and click Go. Whilst I'm doing that, I'll go back to AWS and I'll hit refresh. And I'm going to hope that something's going to pop up there.
Jason, this is a good moment in time to mention that we did not actually talk about any URLs. It's megaport.com, I would assume.
That would be correct.
And and the blog, there's a link to the blog and other stuff that people can read there, or?
That would be right. So megaport.com, there will be the blog there as well.
Okay. And megaport.al, Megaportal, if you will.
Megaportal,
that's the portal.
That's the one that I'm operating at, and you can actually sign up there. There is a sign up button. This is not closed off. You can do pretty much everything that I've done here except for the deployment from that portal, even with just a generic sign up. So it's quite simple to get started. Now, that hasn't connected through for me because I was using the US region, and I think that I had stuffed something up. I'm just going to do the same here in Australia. You love demos on the fly. At least I can tap dance. But the express route circuit should be going off and creating while I'm talking.
Yeah, very quick question. If you're subscribing as a pay-as-you-go customer and your monthly payment runs out, what happens to your circuits?
I think they give you a couple of days grace before they are terminated, but you are given a warning that that's going to happen.
Right.
Has anyone got terminated on a pay-as-you-go plan previously, or what's the?
I can't think of any instance where one would even consider doing it pay-as-you-go.
Well, that's the way the porn sites work.
Yeah, and that powers the internet. Let's be honest.
A friend told me that.
Allegedly.
Well, so James, you might do pay-as-you-go if you didn't know what the traffic was going to be and you wanted to put a cap on your risk.
That's true, and it dramatically reduces the upfront cost, doesn't it?
And pay-as-you-go is really just saying a recurring subscription. So you do start with a credit card. It would only be if you stopped that as a billing method that would terminate. It's still a rolling subscription. It's just it's not an upfront commitment, which is probably what you're looking at for cloud providers. I will note that Microsoft have added a developer program that actually gives you $40 a month of credit, which is probably enough to get started, and that's for 12 months. If you do just go and start with Azure, you can sign up to the portal, and the first sign up from an email address, not that I'm telling you how to circumvent things, the first sign up from an email address will have a free credit attached to that. The problem is it does run out without that month, so it's possible to get a small amount of credit at least to run some virtual machines in that month-to-month basis.
Yeah. It's pretty good, and what grabs me about this is the ease and speed with which you can actually deploy stuff.
I'm glad you segued. So here's that inbound connection. This is actually on Sydney. I've changed back from US East, but you can see I have an inbound request, and that's sitting in pending acceptance. So there's the private AS number. It's automatically picked the IP addressing that's used. That's dropped in on a gig interface because it's a gig connection. And I'm happy to share with you my account numbers because it doesn't actually pull it up until I go accept that inbound request, and that's then tying it through to my virtual machines. Similar with Microsoft, so that request that I put for a demo express route is there, and this is the magic service key. The primary key is this bit here. It's a little bit different, as you can see. I've started the request in the Microsoft side versus on the Megaport side, but it's all the same. So if I go back to the Prey, and I say I want to connect to the cloud, and I pick the Azure platform, I just pop that key in here, and it will go off and actually look for where that maps to. So it knows that that's in Dallas, and you can see the primary and secondary router there. So I can actually say Dallas, take caps lock off, Dallas VUC test. That knows it's a 50 meg per second circuit, and once again I'll just provide the same price, just provide the VLAN that I want it to drop into. And that's all built on the fly. Now you can imagine the to and fro, even talking to the guys from Microsoft when they were building these services, they say, oh yeah, expect it to take about a week or two, but we're doing it all literally within minutes and making that possible worldwide, as you can see. Microphone drop.
Jason, can we talk a little bit about the typical uses for this kind of thing? I mean, it's obvious probably to most people who need it, but for those who are going, wow, what is it? Let's hear about it.
So as you saw there, most of the cloud providers start their sort of drop at 50 megs per second. So you do need to have a fairly good use case to escalate out of. I've been running this over a solid connection over the internet. Mostly when you're doing extension of your private network, so you're running a hybrid cloud environment into one of the public cloud providers, you'll be running a VPN tunnel. And anyone that's run IPsec encryption over internet devices knows that that has an upwards cap. So we start to see people around 20 megs per second. There are devices that will cope with higher bandwidths, but we start to see people going, what next? The other thing, as we know with internet connectivity, is that there's no guaranteed path. You may be running over one part of the internet to get to your location at one part of the day, and then all of a sudden, I don't know, we need to shift traffic, and you're running another path between that has a much larger latency. And that's where the question came up for the start of this, which is, latency and jitter, oh my. Apologies, it's now 2:41. Because with internet services, and especially now running VPN on top of that, what have we got? We've got probably one of the worst performance aspects that you'd want to think to run some of the workloads. Now, it's not going to matter for some, but with voice and video, oh, I see Dave getting his knuckles just cracked. But this is actually building these circuits on MPLS paths. So I have prepared something earlier, which is our published latency figures for Asia Pacific. This is something that we're actively working on, but in order to document these are worst case scenarios. These are one-way figures, so packet transfer delays. And you can see we've caveated the New Zealand to Australia. They have a little asterisk next to them before anyone asks. That's because we protect that path via Hawaii. So instead of just between New Zealand and Singapore, if the primary link was to fail, we're actually going to push that link over a protected path, which is running halfway to the US and back. So that is certainly a worst case. But within the metro areas, you can see we have sub 2 millisecond packet transfer delay latency, and then we have the metro joins. So Sydney, Melbourne, and Brisbane are down the east coast of Australia. Singapore and Hong Kong, I think we're looking at 35 milliseconds between at the moment. I don't have the figures for Europe because we haven't built it yet, but I expect very similar performance. Probably better given the distances are going to be smaller than what we're seeing here in Australia.
So
Go ahead, Tim.
Just thinking about the use case, I was reading the other day an article about, I think it was Dropbox, who decided to move huge amounts of their storage off AWS and onto their own private server farm that they were building. And presumably that's in a big data center somewhere. I don't imagine they're building their own data centers. So am I right in thinking that's a perfect use case for what you're doing? You're saying, well, we've got a ton of stuff to move off AWS into another data center, and we want to do it in a controlled, managed way. But actually, once we've done it, we're not going to want to have invested in a 2-year circuit because this project's over in 6 months.
It's short term, you're right. And there is a cost benefit as well. So I spoke about the connectivity options via the internet. The interesting thing with the public cloud providers, I'll take AWS as an example, but Microsoft have a similar construct. Data in, so sending data to them, completely free. This doesn't shock anyone. They're not going to charge you to get stuff up and running on them. To extract said data, or just day-to-day operations, data outbound from them, in Australia we're probably looking around 12 cents per gigabyte, and that obviously adds up as you keep scaling. You do get some volume cuts on that, but it kicks in at multi-hundreds of terabytes. When you're running these direct connections or express routes, we're looking at a saving of about 1/3 on that cost. So we run from 12 cents a gig down to 4 cents a gig, and that's a flat rate. Which, yes, you do need to establish the circuit, but you don't need to then maintain it for the life of that contract. You're just doing it for the term of when you need to actually dump that data. With these public cloud services, we pretty much give you a flat rate in US and Australia nationwide. So if you're using 1 gig per second, we'll be doing it at that 200 Aussie or 200 US dollar. If you want to do a little bit more than that, it's going to cost a bit more, but pretty much with the distances and the amount that we're doing 1 gig per second into the cloud or out of the cloud is definitely a sweet spot for a lot of people.
So, is the floor open yet?
1 second. Let me just ask one more question, Dave, and I want to get you involved in this. Jason, here's a really simple formula question. I have. If you were in Paris, okay, and I was in Paris, so I've got something that's a short, forgetting the delay, the latency, the latency to Paris for me in my office or my studio, right? And I've got Larry Carlton is in Los Angeles, and suppose you have a point in Los Angeles. So he's connected close enough to that studio, and forgetting any audio latency that there might be locally on our machines in our studios. What kind of latency would we expect between those 2 points? It's not late here, but I can't pronounce between. So
it is late here, and I just heard 2 trains are heading towards each other at 60 miles an hour.
Right. I mean, just a ballpark idea. I mean, is this going to be less than 50 milliseconds? Or not?
So that's the reason I gave you the chart here. The speed of light is fixed. This is a good thing.
Right.
I'm probably unable to speak about the circuits that I don't know about. I'm not going to step in there. But we're seeing certainly...
Hold on, Jason. The speed of light is not fixed. It depends what you pass it through.
Not in water. No, but yes. I mean, that's definitely the concrete limit, of course.
That is something that we're going to be looking at within Europe. I don't have Paris on the roadmap yet, but definitely like to get there. Look, I'm happy to look at some of those figures for you. I can give you what we've got now. The good thing is we're measuring this on our network. We have monitoring in place. So whenever we start to see an anomaly, we can then compare 2 routes. So we do have diverse paths. When something is constructed, you've not needed to think about that or seen that in the web interface. But when that circuit is built, there's monitoring on that to say if something does affect one of those paths, that we have a failover path. And that's all taken care of automatically, that it will actually float that across to the second link.
Okay, so that was kind of a dumb question anyway, but it was just one example of the kind of thing that you might want to do in real time. Let's get Dave Todd in here because Dave had a question. He was ready to
Dave.
unmute yourself, Dave. Go.
All right, so I ended up with 3 or 4. I just took some notes along the way, but if anyone else,
Sure.
you want to do round robin, switch from there. So in terms of your goal as a business, your pursuit of low latency and jitter is first up to reduce the time and hassle required to acquire a circuit from weeks to
Time
hours.
and money, ideally, yeah. Latency that has been measured sometimes in months to get things up and running. There is still a delay, and I'll be quite open in that the first part of what I did was I said I want a port, and there is actually a cross-connect within the data center that needs to be done. So we can see a delay there of a few days to maybe a couple of weeks. It does vary across the world, as you can imagine. But once that's up, everything we intend to build on that virtual side of it, instead of needing to run another physical cross-connect, should be done within 1 to 2 minutes.
Okay. So your underlying transport for all this stuff is actually MPLS. This is what I also heard.
So we are a pseudo wire, correct? Yeah. Now the underlying part of how we actually carry that is on multiple services. So I'm not even saying we're going to, be rebadging someone's MPLS, but think of what we're doing as layer 2 MPLS pseudo wire. Yep.
Got it. So one of the things that puzzles me is that IPs, particularly for IPv6, were hoped to be geographically specific. So when I plug in Australia to England, are you announcing a set of IPs into the BGP table before that, or are you asking the customer to figure out that portion of it?
We're doing a bit of both. So I mentioned there that if you're doing between 2 data centers, we're just doing pure layer 2. That's like, go figure it out. We'll happily carry whatever you present to us. If you're starting to look at the cloud services, if you're using public cloud, you do need to have a public AS number. You do need to have IPs assigned. Not all of the public cloud providers support IPv6 yet. If you're doing private, you're able to pick a private AS number. You're able to use RFC 1918 addressing. However, I did also mention IX, so the Internet Exchange. And they are somewhat Metro Ethernet reliant on those routes. So if I pick an IX here in Brisbane, it's going to present to me a different set of IP routes than I would pick if I was in Sydney. However, that doesn't stop me from actually wanting the content that's in Sydney. Say I don't get Netflix here in Brisbane, but the Netflix routes are in Sydney. I can then run a virtual connection into Sydney and then take the IX from there. So it's actually joining metro markets in that way as well.
I'm sure Netflix will appreciate that.
They do.
So
they're quite happy to fill pipes. I think worldwide is the statement that we hear, and we provide the route servers, and that's the part of the as we heard there, the partnership with AMSIX is that AMSIX have been running a very successful internet exchange in multiple markets around the world. We're not actually joining with AMSIX here in Australia because our IXs are quite well featured, but in other markets where we don't have as many routes, it's actually taking the AMSIX routes, joining them with ours, and AMSIX will run all the underlying infrastructure and backbone. So it's a trusted name that we will join with.
Okay. So I have 2 more if anyone else wants to take it. Okay. So,
you can do a round robin? Okay.
So you also indicated that you were you are not VPNing these 2 connections. They are not encrypted. That is
no, we're not. That still certainly remains an option. I mean, it's as private as it's not on the internet.
Yes.
There is obviously any system that is unencrypted has a risk, but what we certainly see now is that there are a lot of mechanisms to communicate with the cloud providers with transport layer security anyway. So the multiple levels of encryption, if you require it for compliance purposes, you can certainly still implement those. We have a basic security white paper, which, as your question asked, no, we're not encrypting it for you. There's not an added delay there. If you so choose to do so, we'll be documenting those services that are available to the cloud providers.
Okay. And then we get to my chief bugaboo in the world, which is called latency under load. Yep. And you showed a set of what your baseline physical RTTs were. But I'm very curious as to what happens if you do load up those links. What happens to your latency? Averages don't count. Peaks count. I have some tools like Flint, etc. So I was curious, in any given point-to-point link, have you ever tried doing latency under load testing?
I will say that I haven't personally. We have. I'll also indicate those values are one way, so we're measuring packet transfer delay instead of round trip times. I completely agree that yes, there are concerns there. That is a load management exercise for us to make sure that we have the capacity on demand, and part of the availability of the diverse circuits is to make sure that we can cope with load. That it's, if one of those all of a sudden it becomes unavailable and we steer all the traffic over, one instead of spreading it over both, we may see some of that. But however, I do want to note that those figures are SLA figures, and we have 100% SLA. This is not going to appease your question, right? It's not going to suddenly magically fix everything, but I need to explain it because it's more an economics question now. We're doing this month to month. If a customer is not happy and they're not getting the performance that they want, what are they going to do? They're going to walk away. So we do credit that back, and that's why we do have it. We publish those figures. We make it fairly aggressive. It is managed and measured to ITU standards. You do need to fail that test for 3 by 5 minute increments in a row. So it's not an instantaneous, it's not quite an average, but I guess over a 15-minute period you'd see it that way. But there all of a sudden we'll just hand you $200 back. How do you feel?
Well, I still go back to simply wanting to know, for example, do you have an AQM technology in place? Is there something that will keep latencies under control? I buy a gig circuit. I can fill up a gig circuit in a fraction of a second. And I can, many circuits today, get over 100 milliseconds or more of induced latency on unmanaged links. So I'm just curious if you've actually gone and looked at that.
We do have latency management technology. I'm going to say that I don't know what they are, but I'm happy to take that as a question on notice. Part of working this to this audience is to get those questions so I can push them internally because I think we want to make our network better. Definitely come and have a look. There is a section in there under the SLAs. I want you to have a look at it. I want you to tell us what you want to see in there. If there's something that's missing, we're going to be able to do it. We are rate limiting on those virtual circuits, obviously, and we are controlling the overall bandwidth that we have available. It won't certainly say all of a sudden, yeah, you want 10 gigs, we're not going to have 10 gigs to give you, or you can't fill that pipe. But quite honestly, we want people to fill the pipes that they have. It takes advantage of the network investments that we've made.
Okay, thank you very much. I look forward to seeing some of that.
Cheers, great.
There's some really good questions coming out there, and
that's awesome.
And you did a good job there, Jason. You are.
I'll advocate. I'm 3 months in, but I am really enthused by the technology. I come from a UC background. Oh, thank you. I didn't try and dodge. I tried to explain.
Yeah, and in most cases, what we're looking at here is it good enough for the purpose that you want it to fulfill? And in most cases, the answer is going to be yes.
I would answer that once again with compare it to a dedicated lease line capacity. If you are wanting to get something that is completely uncontended that you're able to have and hold yourself, you're going to be paying for it, you're going to be waiting for it. There are the two things that underlying.
Yeah. And time is money in this business.
Time is money, yeah. We have the same target and underlying desire. There's no guarantee that when you go and spend that money and you've actually waited that time and you've got these physical circuits in play, that they're going to use anything other than this as an underlying technology. Hell, we'll happily resell this to people who then don't put our brand on it and put some other brand on it and charge a higher amount of money. So I think that there's a couple of answers to that question.
Yeah, coming back to deployment scenarios,
Sure.
A possible use for this would be for somebody who really wants to deploy a global mobile network operator. Who could that be? Very
possibly
quickly.
Want to do something like that.
Yeah, do something as stupid as that. I mean, that's a ridiculously complicated thing to do. Or, in fact, it would be a ridiculously complicated thing to do, to try and do in the old world, where things take months to set up. And Jason, I have to say that if this kind of stuff was around like 8 years ago, it would have saved us months. And perhaps some of the the performance may not be kind of perfect. But again, we've got to ask the question: is it good enough for what we're trying to do? And you mentioned
for the right customers, I'm happy to share the underlying metrics and monitoring that we use. Put it that way. This is the perennial question with what we do. Because of this being effectively a network abstraction service, we retain the right to change the routing, to be somewhat flexible in the carriers that we use to make this happen. It should all be transparent to the end user. The problem with that is when I get asked, these are the 2 points I want to connect between. Can I have the Google Maps KMZ file of where the fiber runs in the ground? No, I can't give it to you. I can at a slice in time, but what happens tomorrow when we need to change that? I don't want to change your underlying performance metric, but I need to keep this running. I need to keep this service provisioned in a way that you're going to be happy with. Now, effectively, you do that by simplifying it. What's the speed I need to get, and what's my A end and my B end?
Yes. Another useful thing that you mentioned, you just touched on, is this business of honouring the QoS tags.
Yes.
And again, that is something which can be extremely important.
Yep.
When you need to move that 1% of your traffic, which is the really time critical stuff. And if you don't have a network that does honour the QoS tags, you're kind of stuffed, really. So to be able to do that in a manner which is quickly deployable, and I have to say is reasonably affordable. I mean, I'm looking at the numbers that your thing is throwing up there, and I'm thinking, I like those numbers.
And we're happy to share those. I mean, once again, it's possible that those will change in different markets, but that's the pitch point that we have at the moment. I would expect, from what I've seen in all the different markets, conversion costs, etc., we're keeping them relatively stable.
Okay. Slightly different question. Who are the guys behind this? Do we know who they are? Because they're quite smart, aren't they?
They are some very clever people that have been doing it for some time. So let me just pull it up for you as well. Any other questions while I look for that one?
Yeah, I have one, but it's kind of derivative of that. So let's hear that answer first.
Okay. So I can pull up for you the board of directors as well, which is on our website. You're more than happy to have a look. So this lovely gentleman here is Bevan Slattery. He's the founder and chairman. So you can see there, 2010 he founded NextDC. Vision was to become Australia's biggest independent data center provider. Denver Maddox is actually ex-Microsoft. Drew Kelton and Simon Moore are our directors. There's a bit more blurb around if you want to have a look there. But I'll go back to Bevan there for a second. Pipe Networks. Bevan was involved in the construction of what's called the PPC-1, a Pipe Pacific cable. Sold out of those ventures now concentrating on Megaport and some other very related and very intertwined ventures, both in dark fiber and submarine cables. No shock there to anyone.
Yeah, so he knows all about pipes, doesn't he?
Yes, I would say I think that's pretty much the main game.
He knows.
So that, I mean, that kind of answers my question, which was, what's the vulnerability to being? I mean, because basically you're treading on carrier toes to an extent. This is a market that they'd quite like to be in, but none of them are actually swift enough or savvy enough to do. But if you look at some of their kind of, what we're going to do next in the next 10 years, some of them look quite like this. I mean, we all know that they won't actually deliver any of this, but they'd like to think they might.
Sure.
So what's your protection against that?
The other answer is that they have a lot of legacy. When I do see carriers that want to do this stuff, they start with the eyes twinkling and you go, in an ideal world, we'd be able to do as little as you do. But the true answer is that they need to do other layers and other services on top of that, and that's usually what picks them unstuck. When you try and virtualize and you try and do the automation level that we have, a lot of the traditional ways of telco doing telco gets and steps in and all of a sudden gets offended by it. And that's where things start slowing down, because then all of a sudden we've got an approval process or we've got this other step that we have to jump through. We're able to automate pretty much any of those things that you saw on the tiles, and people who aren't a Google or people who aren't a Microsoft or an AWS can also appear as a tile. So if they are running a cloud service, or they're running some virtual machines clustered, or something that we have not even thought about that needs something to be plugged into it, a virtual telco operator, let us think.
Yeah,
As long
well,
as they have an API and would answer that call from the customer and take over that part of the discussion and then run with it, we're quite happy to list them alongside that.
yeah,
The
well,
marketplace is different. It's a bit more analog. It's a bit more step by step.
yeah. That's exactly the line my mind was going.
Mm.
We could assist by adding a whole load of tiles to your whatever you call it, where you keep your tiles, your tile pile.
The tile shop. I
Your
don't
tile
have a name
pile.
for it.
Yeah.
Yes. Okay. So I'm glad that I've started some thoughts there, James. I know that you'd be very keen to see, and I'm sure there's others that would be. Actually, I'm sure you've logged in already and signed up, and you're starting to have a bit of a play around. As I said, that's the best way. That if someone comes and asks me for a quote, I go to this site. This is the portal. Go in, sign up, click where you want to go. It will price it out for you. You can pick the longer terms if you feel like you want 12 months, 24 months, sure, or just go with the 1 month and price it out. You don't it won't get asked for your credit card on
Already
the
in
next.
my mind, I've got the bones of a concept that could be executed in Lisbon later this year.
Brilliant.
Well, this is where somebody is foolish enough to build a complete mobile network operator in the cloud, a global mobile network operator in the cloud, in about an hour.
I see
That would be great.
Nothing.
I see a VUC sponsorship option. But all kidding aside, we probably should, if everything has gotten said, we need to figure out if there's anything that didn't get said yet, Jason.
One more thing. I mentioned it was all API driven. So this site here, dev.megaport.com, I'll put my heart on my sleeve. When I saw this, I thought this is the company I want to be at. The full API is published. All of what I just showed you via the portal is actually achieved by poking at this API. The best way to learn it is to go and log into the portal and start doing it manually. But James, on your point there about hacking this away in Lisbon, have a look at that site and tell me what you think. Definitely very keen.
Well, I'll tell you what I think right now, Jason. My wife is going to hate you because you just buggered up my bank holiday weekend. Because you know what I'm going to be doing over the weekend, don't you?
Funny.
I do.
Dave, you had something you wanted to say before we terminate this segment? About the test? Go ahead.
Well, we've been working on the latency under load tool. It's always been my hope that SLAs would actually stop guaranteeing a packet loss rate and also measuring what their latency under load is. And we've developed a tool called Flint, which is very simple and easy to use. It blows up networks very quickly. And if you could set up a test circuit at some point, I'll gladly play with it with you. And/or I'll talk a little bit about the work I'm doing on Wi-Fi later in this call. So,
cool. Thanks, Dave. Look, that's the sort of stuff I want to have a chat with our engineers. There's some smart guys that have been working with specific instances. I think we've tested them a lot with customer load, but in terms of I'd like to take this and dial it up to 11 and really give it a good test. We've been running IPERF tests, etc., for certain customers, but something that can do the latency under load would definitely be worthwhile, and that's the sort of stuff I want to gather today. Thank you. I appreciate it.
This morning. Cool.
So I have one remaining question, which is, I mean, I really like, I think it's great. I can see use cases for it. I don't have any instantly, but I can see some in the future. But you didn't do a Google Cloud demo. Is that because it's less featureful, or just because you got bored with doing demos?
Well, we do have Google Cloud on there, but it's done in a different way. So if I was to show you the Google Cloud demo, I wouldn't be showing you their side. I'd be showing you our side, and there's not the same level of interaction with the API. Essentially, we are carving up assigning IP addressing for that. It really is the same as a peering connection. So for now, we're setting up the connection with the Google Cloud using an IP space, bringing that to their door. That's the Google Carrier Interconnect product, whereas the others are actually doing a layer 2 tunnel. So I'm getting a VLAN on both sides.
Right. So it's a different product and is, to be honest, slightly less featureful. But if you wanted to get a
Yeah.
ton of data out of Google and into somewhere else, that might be a way.
There's still the concept of that discounted egress rate. So
Right.
yes, you
Cool.
still would achieve that. I can't do that in Australia. That's the one thing. We don't actually have a Google Cloud deployment here, but certainly within our fabric, it's there as you said.
Do they have a data center?
Well, Google exists here, but Google Cloud does not. So
Right, that's
if
what
I
I
was
was
to actually pull one up from within Australia, it would be peering once again, as I mentioned, the IX within Australia and then carrying across their network, and I would not have that cost saving.
Right, got it. Okay, cool. Thanks.
Okay. No
How
worries.
often do you get to hear the word egress?
Egress.
Okay.
It's one of my
I can say
favorite
ingress too.
Egress.
Ingress.
All right, let's seal this up because we have a couple of interesting things going on
Awesome.
in the mature audiences segment. And Jason, if you have the energy, you're certainly welcome to stay.
I don't get to talk to you all that often.
Probably won't happen. Anyway, quickly, megaport.com. Check this all up.
Correct.
Also, check this all
Or megaport.al.
AL, yeah, Megaportal, right? Dave's thing, because we are going to go off public here, so let me remind you that what he said was flint.org, FLENT.org. James, give us the mnemonics on that. Figaro, no.
Foxtrot, Lima, Echo, November, Tango. Thank you.
Excellent. .org. Okay, we're going to seal off the VUC for now. We're going to thank Jason Bordujenko. Jason, when are you coming back to France?
Hopefully very soon. That's what I wanted to show you the Europe plan. So you guys are gotta find the use case, and then I'll be over there.
All right, yeah, and you set up the data center in not Paris, Bordeaux. Yeah,
The best place to data center. Cheers.
No, Manchester.
And London.
Just fly it amongst yourselves and work it out.
Okay. All right, ladies and gentlemen, we're going to go off to the what we call the mature audiences only. So the hangout's going to end. Thank you, everybody, for participating, and thanks to all our viewers and listeners and so on and so forth. We're going to go off. We're going to be talking to Dave and everybody else, but you won't be able to know because we're cutting off right now. You'll never know what happened. Private party.